Hello everyone. Pratibha College of Commerce and Computer Studies organize a course on basics of embedded system design. I, Professor Neeta Gatkal, on the behalf of Department of Electronics, will present a Module 1 Basics Introduction to Embedded System. Let me share my screen first. So, I'm going to present Module 1 Introduction of Embedded System. So, today in the first module, we will see the introduction of embedded system, what is embedded system, components of embedded system, classification of embedded system, applications of embedded system. So first, introduction. We have been very lucky that we have been born and brought up, most of us, in an age of computing. Since our birth, many of you have seen computer systems around you. But of course, the scenario was not same maybe 4 or 5 decades back. But there has been a computing systems, advanced computing systems, electronic devices, low power devices, and all, etc. Computer systems are everywhere today. If you look around, not only for the technical purpose or laboratory purpose, for example, for the residential, when you wake up from a sleep, you will find there are instances where there will be computation devices. Now, traditionally speaking, we have become familiar with the devices, the computing devices like desktop, laptop, servers, mobile phone. So these are the computing devices that we are very familiar. But there are some another type of computing system that is often hidden. Hidden means which we cannot see, often hidden from us. If you like, if you look at the refrigerator or AC, do they look like a computation device or a computation machine? No, but they have some computational devices inside. So that is nothing but hidden from us. So those system we can say it as a embedded system. So going further to the definition of embedded system, first we'll see what is a system. A system is a way of working, organizing, or doing one or many tasks according to a fixed plan, program, or a set of rules. We can say this is an arrangement in which all its units assemble and work together according to a plan or a program. For example, the given example, you can take any example. So for example, a watch, it's a system, it's a time display system. So the watch has different parts like hardware, needle, battery, dial, chassis, strap. So we can say that if we arranges all the units, so it perform a particular task. Okay, so that is nothing but a system. So how to the next point is how to define an embedded system. So an embedded system is a system that has a software embedded into a computer hardware which makes a system dedicated for an application or specific part of an application or product or a part of larger system. So if you see in the diagram, there is a one chip and something written like a hardware on that chip. And in the another part of the diagram, there is something like a code, or we can say as a software program. So as per the direction of the arrow, whatever the program we write, that program is loaded into the chip. So we can say that embedded system is a combination of hardware and software. So here whatever the program we write, that program is loaded into this chip. So the collaboration of this program, as well as we can say it as a software and hardware, makes a one system, and that system is known as a embedded system. So an embedded system is a microcontroller based system which is designed to control a function or a range of function. Now we'll see the next as the components of embedded system. So it has three main components, as it has a hardware, it has a main application software, it has a real-time operating system. So the hardware part contain processor, timer, interrupt control, IO devices, memories, port, etc. So we can say that whatever the controller we use, the controller always has these all features like timers, IO device, timers, memories, and port. So whatever the part related to your processor and controller, that is nothing but a hardware part. Now it has a main application software. So this is nothing but a perform which may perform concurrently the series of tasks or a multiple tasks. And the third main most important component of embedded system as a real-time operating system, or we can say that it is RTOS. RTOS defines the way the system work, which supervises the application software. It sets the rules during the execution of application program. A small scale embedded system may not need an RTOS, real-time operating system. So these are the components of embedded system. Now we'll see the basic structure of embedded system. If you see in the diagram, there are different blocks are given. So the first one is the sensor, the second one is A dash D converter, which is also called as analog to digital converter. Then the third block is the processor. The fourth one is a D-A, which is also called as digital to analog converter. The last one is actuator. We can say here we can use as a display. And there is one more block called as a memory. So we'll see one by one. So sensor is nothing but a one the conversion sensor do the conversion of one form of signal into another form. Basically whatever the sensor we use, that sensor convert any signal like temperature, pressure, humidity into a electrical signal. But now the third block is the processor, or we can say as a controller. So here whatever the processor or the controller, that device knows only data in the form of ones and zeros. Now, at the output of sensor, we get the data in the form of voltage or current or any electrical analog signal. So, as the controller knows only the data in the form of ones and zeros, we need to convert our analog signal into a digital signal. So there we use the second block known as a analog to digital converter. So sensor convert the signal, the particular input signal into a electrical signal, and that electrical signal is in the form of as an analog signal. It's converted into digital signal through this analog to digital converter. Now the third block is the processor, and you can say that this is a ASIC is the application specific integrated circuit. So here it receives that data in the form of ones and zero, and that is processed. So in place of processor you can use also the controller also. So basically here whatever your data that is processed or that is controlled by this block as a processor or application specific integrated circuit. But again, for example, you can take the example as a temperature tem- uh, temperature display or a temperature monitoring system. So what happened in the temperature monitoring system? We use the temperature sensor, so it senses the temperature, and monitoring system means it displays something data on a particular display. We can say as a LCD or any LED display also. So whatever the data you want to display, again, the data we the output of the processor or converter we get controller, we get the data in the form of ones and zeros. So that data again needs to convert into a analog form. So that is to be done by a digital to analog converter. So here there is one more block known as a digital to analog converter, and the last one is here actuator. Okay, which is exactly the actuator perform the operation exactly opposite of your sensor. So it convert that whatever your electrical signal into the signal which the human understand. So this is about, and there is one more block known as a memory. So this memory is used to store the data. Okay, so some processor some controllers have inbuilt memory, but there are previous whatever the systems we use there where the controller or processor where we need to externally interface the memory. So this is about the basic structure of embedded system. Now we moving forward to the in detail about the processors in a system or a controller in a system. So the first is the processor in a system. So processor is the heart of embedded system. It is the basic unit. It is a basic unit that takes input and produces an output after processing the data. For an embedded system designer, knowledge of microprocessor and microcontroller is must. Okay, so we'll see in detail about the processor and microcontroller also. But the processor is the heart of any embedded system. Now, the first we can say as the microprocessor. So, what is mean by microprocessor, and how to we can say what is the block diagram of or how to interface some devices with the processor. So here microprocessor is a single chip. Microprocessor is a single chip semiconductor device, also which is a computer on a chip, but not a complete computer. So we can say that this is also a chip, but this is not a complete computer. So to make a complete microcomputer, to make a complete computer, we must add memory, usually a ROM, a RAM, a number of serial and parallel port. So if you see the simple block diagram of a processor, it has the first block is nothing but your CPU, that is nothing but the general purpose processor. So this is a CPU. So to make a particular uh, to complete computer, we externally connect these all devices like a RAM, a ROM, IO port, timer, serial compo. So this is about a microprocessor. So basically this is a chip and which is used to process the operation. And why the name is micro? Because this is a very small. So that is why the name is micro. Now the next one is the microcontroller. So in the next module, you will come to know what is mean by microcontroller and what are the different types of microcontroller available and how to use the microcontroller for an embedded system. So I will just go in a short about the microcontroller. So microcontroller is a single chip VLSI unit. A microcontroller is a functional computer system on a chip. It contains a processor memory, and programmable input output peripherals. So basically, this is again a single chip. And if you compare this microcontroller with the processor, you may get an idea about how what is the main difference between processor and controller. So in the processor, to make a complete computer, we need to externally connect these all the devices. But if you see here, the microcontroller is a functional computer system on a chip. Means it has inbuilt RAM, ROM, IO, that is the input output devices, timer, serial compo. So microcontroller is a functional computer system on a chip. It contains a processor, memory, and programmable input output peripherals. So this is about a microcontroller. Now, developing a embedded system, as we know that embedded system is a combination of hardware and software. So till now we discussed about the hardware as which type of what is the function of processor or what is the function of controller. So this is something related to the hardware development. So the most important is again the second part is nothing but a software development. So embedded system development classified into two parts as a hardware development and a software development. So developing an embedded system. So the first one is the hardware development. So this the hardware development. This include choosing the right microcontroller unit for your application. Means if you want to design a particular embedded system, the particular for a particular application we need to choose the right microcontroller. So the choosing the right microcontroller for your application is very important. So there are some criteria for choosing a microcontroller. So the first is the number of IO port, second serial communication module, the third peripherals like timer, analog to digital converter, pulse width modulator, etc. The fourth one is memory requirements. The fifth one is processing speed required, and the sixth one is power requirement. So these are some criteria for choosing a microcontroller while developing your embedded system. Now the next one is the software development. Okay, now which type of language we use? Which type of language we use. So if we use, as we know that there are different type levels of language as a high level, low level, middle level language. So here if we use a high level language, there we use a compiler. So compiler which compiles your code, means which convert your high level language into a machine code. At the same time, if we write the code in a low level language, for example, the low level language we can say it as a assembly language, and for high level language we can say as a C language. So if we write the code in a assembly language, there we use a assembler. So assembler convert your assembly language into a machine code, as well as compiler convert your C language into a machine code. So there we get a hex file. Then we use a particular programmer. So that programmer load over that hex file into a chip, or into we can say as a program memory. So this is the software development part. So the combination of hardware development and software development makes a embedded system. Now we're going further as the classification of embedded system. So the embedded system classified into three main uh, types, three main parts, as a small scale embedded system, medium scale embedded system, sophisticated embedded system. If you can see the diagram as a small scale, what is the structure of small scale, which type of controller, or how many pins for the small, how many pins of the microcontroller are there for the small scale embedded system. If you go for medium scale, and if you see it for the semi sophisticated embedded system. So we'll see one by one the types and the the parts of the embedded system, the types of the embedded system. So the first is the small scale embedded system. So small scale embedded system, this is nothing but a single 8-bit or a 16-bit microcontroller. So this embedded system contain a 8-bit or a 16-bit microcontroller. So it has a little hardware and a software complexity. They may even be battery operated. So it is very small because this is battery operated, and usually C is used for developing this system. So whatever the language which is used to develop the software, so that is nothing but a C. And the programming tools like editor, assembler, and cross assembler. So this is about a small scale embedded system. Now the next one is a medium scale embedded system. So it contains a single or few 16 or 32-bit microcontroller, or we can say that it contains digital signal processor or reduced instruction set computer. So both it have this medium scale embedded system have both hardware and software complexity as compared to the small scale embedded system. And the programming tools which are used like RTA, that is the real time operating system, source code engineering, simulator, debugger, and integrated development environment. That is IDE. Now, the next one is the sophisticated embedded system. It has enormous hardware and software complexity, so which may need a scalable processor or a configurable processor or a programming logic array. And the programming tools which are used like a compiler or a retargetable compiler might have to be developed for this. So this is about the classification of embedded system. Now we see the last point of this module, that is nothing but the applications of embedded system. Everywhere we use the everywhere we can see the embedded system in day-to-day life. For example, we see these are used in different applications like automobile, telecommunications, smart cards, missiles, satellites, computer, and networking. So embedded system used in automobiles and telecommunication like motor and cruise control system, body or engine safety, entertainment and multimedia in a car, e-com and mobile access, robotics in assembly line, wireless communication, and the last mobile computing and networking. So this is something related to the automobile and in telecommunication where the embedded system are used. Now the embedded system in smart cards, missiles, and satellites. So for example, the security systems as a smart card. Without the cards, no one will allow to enter in the particular hall or a particular home. So the first is the security system. Then the telephone and banking. Nowadays we use the cards or the cards for banking. The third one is defense and aerospace, and the last one is communication. Embedded systems in peripherals and computer networking. So, for example, display and monitors, networking system, image processing, network cards, and printers. Embedded system also used in consumer electronics like digital cameras, set-top boxes, high definition TVs, DVDs. So here these all are the applications of embedded system. So This is the first module that I explain as the introduction to embedded system design. So in this course, we shall be we shall be talking about the various aspects of embedded system design. Uh, Embedded system design, like which are the controllers are used, which are the different boards we can use for the embedded system design, like Arduino, Raspberry Pi, and the controller like 8051. So we'll study this embedded system design in the in further modules. So here we finish. Here I finish with the first module as the introduction to embedded system. Thank you.